Hello, everyone. Welcome to Theo-MathProblemSolver. At this point, I'm so excited to take you through the journey of trigonometric integrals. Even though this section has already been treated, in which is trigonometric integral, it has already been treated, but I've got one or two comments from students and who sort of needed a strong foundation in trigonometric integral. So I thought wise that I would touch on one or two things just to help strengthen your understanding of trigonometric integrals. And this today happens to be your first time, please subscribe, like, comment, and share, and to help, demystify the myth around mathematics. So let's get going. All right, so we have this problem, which is to evaluate this nice integral problem. Now, just simply substituting, u equal to. That's how maybe some student may approach this problem. Just simply substituting u equal to cosine uh, of x, may not be helpful. Will not be helpful since you look at it that since the u equal to minus sine x, dx. Okay, it looks like my pen is not will not be helpful. So this will not be helpful. Okay. So what we are going to do is that um we would need an extra sign factor. Okay. So to do this or to solve this problem, we would need an extra sign factor. Similarly, a power of sine would also require an extra cosine factor. Thus, here we can separate one sine factor, sorry, cosine factor, and then convert the remaining cosine square factor to an expression involving sine using the identity sine squared. I know this is a very popular one. My pen for some reason is messing up today, but we'll overcome this. So this is a very popular identity. If you have been following us, you will know that this is a very popular one. So we are going to use this a lot in our discussion. Now, so basically what we are going to do is that we are now going to convert the integrand, which is cosine cube, okay, of x into in a way that we can deploy such a term. Okay, so let's see how we are going to treat that. So which means that the cosine cube is equal to, so we can write it in a way that um, we can have a factor of cosine. Okay, so that we can use this now. So in other words, this could be written as nice as this. Okay, but over here we see that we can just make from here we can just separate the cosine squared x out. Can we just do the separation of that? And by doing that separation, we're going to have something as this. Does that make sense? Good. So which means that over here, I'm gonna sub in the identity for or the expression for the cosine square in over with this. Okay. So we're going to have 1 minus sine squared x cosine x. Okay. So now this is now going to be our new integrand. Okay. Very good. So now let's now push in into the problem. So now our cosine cube, the integral of that is now going to be 1 minus the integral of 1 minus sine squared x cosine x dx. Okay. Now seeing this, now it becomes so simple to then use the method of substitution, right? So we'll say that let u, okay, so we'll say let u to be equal to what? What do you think? To be equal to sine. Good. Then what then becomes now, since we are converting everything from x to u, it makes sense that we also do certain things that needed to be done in order for us to do the conversion. Okay, very good. So let's get good. So it means that our du should now be equal to what? The cosine of x dx. Okay. All right. Now you see that this expression that we just got here is just directly what is here, right? It's just what we have here. So we can, it means that in place of that, we can just deal with it as well as our du. Okay, good. So now with that, it means that we can now have the integral to be 1 minus, this is replace u as sine, so that we're going to have 1 minus what u squared, and then cosine x dx is now our du. Okay, does that make sense? This now becomes easy, right? So by using the properties of integration, we'll get u. When we integrate one, we have u. And when we integrate u squared, we're going to have what? U cube on u cube on the cube, right? Very good. U cube on 3. Very good. Very good. So because we said that increase the power by 1 and divided by the increased power, and that's how come you have something as this. Does that make sense? Then we add a constant c, and we said that this constant is the constant of integration. So which literally means that it's just an arbitrary number, which means that this particular solution is not unique. It's just a family of solutions. Okay. So um in general, we say that we try to write an integral involving powers of sine and cosine in a form where we only have one sine factor and the remainder of the expression in terms of the cosine, or only one cosine factor and the remainder of the expression in terms of sine. So the identity, as I mentioned, which is sine squared plus cosine squared equal to 1, is a very powerful tool that enables us to solve problems involving issues like this. Okay. All right. So let's get going.